In this lecture, we'll learn how to find the range of a function, a composite function, and that of a quadratic function. For example, if a function is given to us, the function is g of x equals to x plus 2, and they have asked us to find the range of this function. And there is one condition, which is x can be any real number. Okay, so the range of a function is always determined by its input values. Now in this case, if x can be any real number, our range of this function will be g of x from negative infinity to positive infinity, because we can put x any number. We can put x as large as possible and as low as minimum as possible. Now if we had a condition that x is, let's say, they would have told us that they would have restricted the domain, which is, let's say, x is greater than 2. Now domain is the input of the function. Now the least value of this function will be, as you can see, it's quite easy to find. It will be g of 2 equals to 2 plus 2. Now this is the least value of the function, right, which is 4. Now all the other values will be greater than this value, which is quite obvious. Hence the range of the function for this condition will be g of x greater than 4. What if they would have given us the condition that x is less than 2? Now for x less than 2, our input will be, and the least value or the maximum value of our function will be 4. So all the other values will be lower than this value for x less than 2. So our function, the range of our function for this case, for this scenario, will be g of x less than 4. Now what if they would have given us a range for the input? Range is the span of the values. Our domain would have been, let's say, from 1 to 10. Let's say the condition here was x from 1 till 10. So our range of the function g of x will be, g of 1 is 3, from g of 1 to g of 10, because it's a straight line function. The graph of the function is a straight line. This will give us 3 to 12. Now what if they have given us a composite function and asked us to find its range? For example, if they have given us to find the range of g of f of x, let's say g of f of x when x can be any real number. We know that g is x plus 2, and let's say f of x is given as 3x plus 4, and g of x is given x plus 2. First of all, we need to find the function g f of x. That will be quite simple. The output of f of x is being put in g of x. That will give us 3x plus 6. Now for x can be any real number, the range of this function will be again from negative infinity to positive infinity. It perfectly makes sense, because you can put the value of x as high as possible and as low as possible. But what if they have given us a specific range for the domain, for the input of x? For example, what if they have asked us to find the output of this function when x was, let's say, from 0 to 5? We know that the lowest value of this function then will be g of f of 0, and the highest value of this function with this domain will be g of f of 5. So this will give us 6, and this will give us So the function goes from 6 to 21. So now we'll learn how to find the range of a quadratic function. Let's say we're given the function f of x equals to 3x squared plus 4x plus 4. We know that the vertex of this function will be at minus 0.667 and the y-coordinate of the vertex will be 2.667. This has been completed by using the formula minus b over 2a and f of minus b over 2a, right? Now if they have asked us to find the range of this function for any value of x, now for that the range of this function will be, we know that this function will have a minimum value because this a is greater than 0 and that minimum value is this 2.667. So no matter what the value you put in it, the minimum value will always be 2.667. So for all values of x, the range of this function will always be greater than or equal to 2.667. Now what if we have been restricted? For example, our domain has been restricted. Let's say our domain is from minus 1 to 5. Now here is the tricky part. The vertex of this graph lies on minus 0.667. So as you move on further from minus 1 to 5, the value actually decreases, then it increases. Now the graph of this function, if we were to draw it, is somewhat like this. This is our graph. Now this is our lowest point, which is minus 0.667. This is the lowest value of the function of the output is 2.667. Now we are actually moving from this point minus 1 all the way up to this point 5. So our value, the output value of this graph, it actually decreases, then it increases. Hence the output value of this graph for this domain will be, you can guess it will be from 2.667 till 99, right? Because this is our least point and this is our least value. So you have to take greater care, a great precaution when finding the range of a quadratic function. You actually have to know its vertex. Only then you can find the correct range of a quadratic function for a given domain.